Yes. Yes. Good day. Yeah. Welcome to my channel. Today I'm back again with more physics questions. Yeah, for practice. Yeah, we can only pass physics if we practice. Practice. It's a subject that needs a lot of practice. Today the topic is kinematics and motion in a straight line. Yeah, we're not yet doing circular motion. That is will be covered later. Right. So let's get straight into this. It is a displacement time graph that we are given. So we have displacement here in meters, right? So the car accelerates uniformly from rest for the first 4 seconds, and then from 4 seconds you can see the curve is going like that, unhappy. It means it's decelerating until it stops there, because from that point, if the displacement is not changing. Good. Right. Let's start by defining what acceleration is. Who can help there? Yes, good. So displacement is change in position, yes. Good. But I think the best also, it is also good to realize that displacement is always measured from the starting point. Like on a graph, you have to look vertically along the axis from a displacement of 0, right? Like if this was, let's say, 50 meters there, so it means at that point, it is 50 meters from the starting point. It's always measured in a straight line from start to the end point. That is displacement. Good. Like the way, before I look at the questions that were there, let me say that to understand the displacement time graphs better, it is always best to apply the calculus, the knowledge that we have in calculus, to understand how these graphs come about. For example, if in calculus we know that in mathematics, that if you say a curve like that, it is a head curve, y equals x squared. Yes. If it's unhappy, y equals minus x squared, right? Okay. So if you differentiate this, you should get a straight line graph. So let me start with the displacement type graph, which is kept upwards like that. So if you could have a displacement versus time graph, which is like this, it is of the form y is equals to x squared. Good. And if you differentiate that, get the first derivative of that would be 2x, which is a straight line. So if you differentiate a displacement time graph, you get a velocity time graph. So you would expect that if you plot from here, for the same situation, let's say from there to there, same situation, if we are asked now to draw for the same time period, the velocity time graph would be a straight line here, because the gradient of a displacement time graph is velocity. You get a straight line for the same situation. Right. So if we were to draw an acceleration time graph, the same situation, let me draw an arrow like this, it would be gradient of a straight line. Let's differentiate that. It would be y is equals to 2, the constant. So you get an acceleration time graph, which is just, let's say it's 2 there. It will be a graph like that. Right. So you can continue to differentiate. If this was y, you differentiate the constant, you get or what you get in displacement, you get 0. Yes. So your math is good. You get 0 there. So which means what I want to say is sometimes your displacement time graph is a straight line, or it can be like that, like in this case. So if you want to define the velocity there, you differentiate the straight line, you're supposed to get, if you differentiate the straight line, you get a 0. So, okay, let's assume that this one, the velocity time graph is your displacement time graph. Then this one, the acceleration time graph will be your velocity time graph. So if this is velocity and this is displacement, your acceleration versus time graph will be Well, if you differentiate that, you get 0. So the graph, the line will be on the x-axis like that. Okay. I hope that is clear. So now I'll go straight into the question, which was like this. Let me try to write. They said the gradient at 2 points, I've already drawn this. You put a tangent there, the gradient is 8. Prove that the acceleration is 4 meters per second squared. So, of course, this would be change in y over change in x, but in this case, it will be change in x unless this is horizontal motion. It's vertical motion, it will be change in y over change in t. Yeah, but it doesn't matter. Well, it's given already. So it is meters per second, but it's given as just 8, but it's measured. Obviously, it's a clue that it is velocity, because the gradient of the displacement time graph is velocity. So it's given as 8. Prove that the acceleration is 4 meters per second, so between 0 and 4 seconds, but we have to get the acceleration is uniform up to there. So you can say now gradient is 8, so the velocity can use v is equal to u plus 18, right? So which gives us the v is equal to u plus 18, the gradient you are given 8. So it's the velocity there. It's given indirectly, and then the initial velocity from rest is 0 plus acceleration which one find, and the time is 2. So you get 2a is equal to 8. So a is equal to 4 meters per second squared. So that is your acceleration. Once you've got the acceleration, they will ask you to find they ask to find the velocity at 4 seconds. You can use now the same equation. V at 4 seconds is equal to 0 initial velocity plus acceleration 4 times 2. So times 4. 4 times 4. So the velocity at 4 seconds would be 16 meters per second because it was accelerating. Remember, so the velocity was increasing. Yeah, good. Was increasing. It was a straight line, so it was increasing uniformly. Well done. I hope that clarifies. And then the next question, they say state the velocity at 6 seconds. State means you don't need to calculate. If you see the word state, you don't need to calculate. Thank you so much. I hope you enjoyed. Don't forget to you send me questions via email. My email address is ramasmazodze, right? All lowercase, my first name, surname, at gmail.com. And if you want online lessons, please get in hold of me. Let's be the best. We want to improve this world. Yeah, we still need to do a lot of research to keep moving and to keep the world safe through technology. And physics is one of those subjects, and mathematics that can help us to get a better world. Thank you.